Okay. Module 2, Lesson 7, the relationship between visual fraction models and equations. We've been looking at using tape diagrams and number lines to help us divide a whole number by a fraction, divide a fraction by a fraction, and we saw that when we were using models to divide fractions by a fraction, what were we using? We needed to have what? To divide a fraction by a fraction using models, the fractions had to have common denominators. But let's face it, if we're in the middle of Kohl's looking to find a fraction of a number or a fraction of a fraction, I'm not about to take out a gum wrapper and start drawing tape diagrams in the middle of the store. So today we're going to look at transitioning from those models to equations. And those equations might look familiar from a trick or a shortcut you used in elementary school, but today we're actually going to understand what that means. Okay, and you're going to figure out the equation from the models. So you just have to promise that you're going to bear with me. In the beginning, it might kind of be like you're raking through mud, but we're going to crawl through it, and at the end, you're all going to go, oh! And if you don't go, oh, I'll come to extra help, and then you'll go, oh, okay? Okay. 3, 2, 1. So let's take a look at the first example. 3/4 divided by 2/5. If we were using just our models, we would have to find common denominators. So let's live on the edge a little today. Let's not use common denominators and figure out how we could just write a simple equation to divide fractions by fractions. So first, let's write what we have been writing. When we saw a whole number divided by a fraction, we found it easier to say 2/5 of what number is 3/4. I like writing it that way because I feel like it just helps me create my tape diagram. For today, we are using tape diagrams still to help us transition to the equations. Tomorrow will be just the equations. Okay? So 2/5. So let's see 2/5 on our tape diagram. 2/5. When I write my sentence this way, I think it's easier to see the relationship that 2/5 is 3/4. So 2/5 is 3/4. So who has a question right now? Why did you shade in 2? Why are there 5 in my tape diagram? Why did you write 3/4 under the 2 highlighted? Who has a question?
Why did you write 3/4?
Because here, 2/5 is 3/4. Those are both parts. Okay, those are equal parts. So my 2 out of 5 is 3/4. Is equals 3/4.
Why wouldn't it be 3/4? No.
So let's continue. Now, bear with me. Okay? We can do this. So, whoa, maybe we can't. Okay. So, 2 of them equal 3/4. So we have to figure out our constant. We have to figure out what one of them is. So how can I take my 3/4 and split it up so that I can find the value of each one? So I could take 3/4 and divide it by 2. Hell devil. But basically, when I have 3/4 and I'm dividing it by 2, each box is getting half. Half. So I'm taking 3/4. I want to find half of 3/4. This is great. Okay. So that 3/4 has to be divided into 2 boxes. So I have to find half of 3/4. what does of mean? This is like a little timeout over here. We're doing a little timeout lesson over here. What does of mean? What operation does of mean? Times. So isn't that the same thing as 1/2 times 3/4? Yes or no? Multiplication means I can switch the order because of the commutative property. So hang on a second. So does that mean that multiplying by 1/2 is the same thing as dividing by 2? We looked at this last week or the week before. So this is a little hint of where we're going with writing our equations for dividing fractions. But this is a little timeout. We're going to get back to our model. So getting back to this, boys and girls. So 3/4 times 1/2 is what? Everybody? 3/8. Who's confused where the 3 came from? Who doesn't know where the 8 came from? Okay. So that means 3/8 is my constant. Everybody with me so far? So far so good? You're bearing with me? So now to find that whole number that we were talking about here, of what number, how many 3/8 are there? What do I do? What do I do? So now I'm going to take my 3/8 and try to erase it. 3/8 times 5. Because there are 5 of them. I want to know my total. Is everybody comfortable with why we're multiplying it by 5? So 5 is the same thing as 5/1. 3 times 5 is 15. 8 times 1 is 8. And then that can be simplified to 1 7/8. Okay, watch me be amazed. This is still a couple of steps. We're trying to simplify the steps into a simpler equation. So let's pretend for a minute, I'm going to come over here and just give you a what if. If I did 3 times 2, that equals 6. If I then did 6 times 4, it equals
34.
Can I just do 3 times 2 times 4 and get 24? 3 times 2 is? Times 4 is? 24. So I could take this step and put them in the same equation, right? So let's do that. Let's take a look at what we just did. So here I multiplied by 1/2. Then I multiplied by 5/1. Yes? Still with me? Okay. So why don't we combine those into one equation? Because remember, our goal of today's lesson is to take that model and figure out an equation. So now let's rewrite that. 3/4 times 1/2 times 5/1. Everybody comfortable with where that came from? I just simplified it from 2 steps, sort of, kind of, into one. I'm going to simplify that even more. Watch this. Watch and be amazed. What is 1/2 times 5? Let me reword my question. No, let's not. So I'm going to keep my 3/4. 1 times 5 is 5. 2 times 1 is 2. So did I just simplify my equation more? Wait a minute. Wait, OMG is right. Are you ready for mind blown? Watch this. What was our original equation. What was our original equation?
It's just flipped.
What?
Say what now?
Say that again.
No,
So we kept our first fraction, changed the division to multiplication, and flipped. I don't like that word. Flipped. So you mean to tell me? You mean to tell me that dividing by a fraction is the same thing as multiplying by the inverse? And G. So the purpose of all of this was to see the relationship, to understand what multiplying by the inverse means. You do not have to do all of these steps on your homework. I'm going to show you exactly what I want to see. This was showing you, boys and girls, this was showing you what it means. Instead of just learning steps and not knowing why you're doing the steps, this was showing you the meaning. So on the bottom of page 31, if you have room, if you don't have room on 31, you can turn to page 33, and I want you to copy the definition of reciprocal, which is also called the inverse. So the reciprocal or inverse of a fraction is the fraction made by interchanging the numerator and denominator, or as you young kids used to call it, flip. Good. Okay. But now that we're cool middle schoolers, we're going to say multiply by the inverse. We are going to say multiply by the inverse. So if our original fraction was a proper fraction, our inverse will be improper. If our original fraction is improper, the inverse will become a proper fraction. So now, let's try two more examples, and I'll show you the exact steps that I want to see. So for tonight only, I'm going to ask you to continue doing the model. Tomorrow, we will use just the multiplication method. And what's really awesome about knowing this multiplication method, and gentlemen, and the model method and the number line method, is that you have resources to check your work. So you'll see on your quiz on Tuesday, it'll ask for a model. And when it asks for a model, you can use the tape diagram or the number line. But it says if you have time, you can check your work using this multiplication method. So it's nice to have that backup. So let's practice exactly what we're going to do here. So turn your page over. We're on page 32, exercise 1. 1/4 divided by 2/3. So 2/3 of what number is 1/4? 2/3 of what number is...
Oh, do you want us to show the steps?
I'm going to show you exactly what I want to say. This is exactly what you're going to do. In fact, I was even going to tell you to write, use this work as a reference for homework. So the first example we did was just to show you the concept and the meaning. Exercise 1 and 2 that we're going to do now is exactly what you should be doing for your homework tonight. Just to show the bridge between models and equations. Tomorrow we will have finished crossing that bridge and we'll be in equation land.
Okay.
So 2/3, let's highlight the 2/3. Boys and girls, please stop talking and stay with me. So I see that 2/3 is 1/4. So 2/3 is 1/4. Does anybody have a question with why I shaded 2? Why our tape diagram has 3? Why the 2/3 is 1/4? So write that sentence.
Do you always draw a model for the second one or the first one?
They mean the same thing, but I think by writing it this way helps me set up the model. Okay. So So now let's take a look at what we're doing. We're taking 1/4. What do I have to do to my 1/4? What do I have to do to my 1/4? Oh my goodness, you're so awesome. Okay, so first we're going to multiply it by a half. Because 1/4, half of it's going in the first box, half of it is going in the second box. We're dividing it by 2, right? And if we have a pizza and we're dividing it by the 2 of us, you get half and I get half, right? But once I divide by half, that gives me my constant. Once I know my constant, what would I do with that to find out my total? What would I do?
Multiply it by 3.
Multiply it by 3. Multiplying it by 3 is the same as, who asked me that question before? About why did we put it over, right, I thought that was you. So a whole number, when we're multiplying a whole number and we want to make it a fraction, we put it over 1. I'm going to condense those 2 steps. Instead of multiplying it by a half and then multiplying it by a third, 1/4 times 3/2. Who's not sure where 3/2 came from? Because when I'm multiplying fractions, whoever's watching this home probably just got dizzy because I was flipping it up and down. 1 times 3 is 3, and 2 times 1 is 2. So when we're multiplying fractions, we multiply our numerator by numerator, denominator by denominator. Okay? I'm just going to move those so you can see them. And now, wait a minute. Ah! What was our original question? Equation. What was our original equation? What was it? 1/4 divided by 2/3. So our first fraction stayed the same. We changed the operation, so we multiplied by the inverse. Because 2/3 is the 3/2 is the inverse of 2/3. So we can see where that came from. We can now see from that model where multiplying by the inverse came from. So 1 times 3 is 3. 4 times 2 is 8. So 3/8 is our answer. I want to get through the next one, okay? So let's get through the next example. So the next one, 3/4 of what number is 2/3? So I need 3/4. So 3/4 is 2/3. And now wait a minute. I have to take that 2/3, and how many am I breaking it into? 3. So I'm taking my 2/3, and if I'm breaking it into 3 groups, we each would get 1/3. Now we're multiplying it by 1/3 because I have to separate it into 3 groups. After I divide it by 3, I would get my constant, and then I would multiply it by 4. And 4, because there are 4, so 4/1. I can combine those 2/3 times 4/3, and that is 2/3 divided by 3/4. That is just multiplying by the inverse. This part you don't have to, but the rest you do. So 4 times 2 is 8. 3 times 3 is 9. So on your homework tonight, I want to see the model. I want to see your 3 multiplication steps. I want to see your 2 multiplication steps. And I want to see your quotient circled. Tomorrow we will use just multiplying by the inverse.